guys, welcome back. I hope that you had a great weekend, that you found something to keep you busy, that you've been being creative and doing lots of work, and I'm excited to teach this week's lesson. So I just want to do a quick recap on everything that we've been learning. So if you remember, before we left for all of this craziness, we did graphing. By the way, these are my math nerd glasses. So, I had to put on full math nerd for this. And we found the solutions or roots by graphing and finding where it crosses the x-axis. Then we learned the factoring method and the master product factoring method. So that's the one that you learned last week. And that's where you factor using the x game, split and solve. And again, you're still finding the roots where it crosses the x-axis. Then last week, you learned the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. You escaped listening to me sing that every single day. So I hope that you watched the video and you got to see the weasel singing it. And the quadratic formula, you get it equal to 0, just like you did here. And then you do a, b, and c, plug it in. And again, you find what x equals, and you're still finding those roots. We're going to learn one new method today. And that method, and this is the last method you have to learn, is called completing the square. I want you guys to take a second, pause the video, and make notes on all of this. So that way you have it written down and you can reference it for the summative activity we're going to do next week. So pause this video and take notes on this. Hi guys, this is going to be completing the square. So if we were in class, what I would have had you do was factor each of these on your own, and you would have factored them to these. And what you would have found is that in each case, it was exactly the same thing in both parentheses. So another way we could write this is x plus 3 squared, because we're multiplying it twice. X minus 5 squared and x plus 6 squared. These are all called perfect square trinomials, and what's special about them is the same number twice multiplies to this last number, the constant, the c, and adds to the middle one, meaning that this last number will always be a perfect square. 36, 25, 9. Can you think of other perfect squares? 100, 81, those are all great ideas. So now we want to think backwards. What would this last number be to make this a perfect square, this missing number here? Well, if we think about it, what would the factors have to be? Well, what number plus itself gives you 20? Oh, it's got to be 10. So it would have been x plus 10, and then 10 times 10 is 100. So that's what would have gone there. Here, you think, what number plus itself is 4? Oh, 2 plus 2. Well, 2 times 2 is 4. How about here? So this was 10 plus 10, and then 10 times 10. This was 2 plus 2, 2 times 2. So what plus itself gives you negative 16? Negative 8 plus negative 8. So if you multiply negative 8 times negative 8, you get positive 64. Again, all of these last numbers are perfect squares. If you want to pause it and try the challenges out, go for it. Next, we're going to take notes on completing the square. Please write these in your notebook. So, step 1 is you have to get it equal to 0, just like we did in the other ones. So here, I'm going to add 16x to both sides. And then I have 2x squared plus 16x minus 20 equals 0. Good. First step done. But I want to have just x squared in the front. Just like in all of these examples, it had just x squared in the front. And same thing here, just x squared in the front. So we want to have that here. Well, what would I have to divide by to make that happen? I'd have to divide by 2. So I'm going to divide everything by 2, and whatever I do to one side, I do to the other. So I end up with x squared plus 8x minus 10 equals 0. Perfect. Now, I want to get it to look like these, where there was nothing over here before. Okay, so that's my goal, is to get it to look like that. So what I have to do then is I have to move, the 10 to the other side. So that's your C term. So you're going to move this 10 to the other side, or to always the number without the variable. So you have x squared plus 8x. Leave yourself a blank space, so it's going to be plus something, equals 0 plus 10, gives me 10 right there. Okay, so now I am going to make this a perfect square trinomial. So we just think to ourselves, what number plus itself gives you 8? Oh, 4 plus 4. Awesome. So then 4 times 4, that gives you 16. Another way to think about it is you take that middle term, the 8, and you divide it by 2. Well, 8 divided by 2 is 4. That's how we got that. And then you square that. 4 times 4 is 16. We're going to add that number 16 to both sides of the equal sign. So I'm going to add 16 to both sides of the equal sign. Because remember, if you do something to one side, you have to do the same thing to the other. Okay, so now my next step, so I added it to both sides, is I'm going to factor this. But what's awesome is that we know, just like here, it's going to be the same thing twice. It's really easy. It's just whatever that number was. So the factoring part's always the easy part in this problem. So we just know it was the 4 plus 4. We got it. So the factors are going to be x plus 4, x plus 4. And they're both positive because the 8 was positive. So the two numbers are positive, equals, and we can combine the like terms, and that gives us 26. Now, remember that if we have the same thing twice, we write it like this. So we're going to rewrite as x plus 4 to the second power equals 26. Awesome. I need to get rid of a squared. Now, if you remember, how do I get rid of that squared? Well, I remember back in the day, we got rid of a squared with a square root. And that's exactly what we're going to do now. So, to cancel out the square, I take the square root and whatever, and then that cancels out. But remember, if you do something to one side of an equation, you have to do it to the other. So I have to put a square root here. Now, this is the one thing. I'm going to just slide my notes up a little bit. Okay, we have to put the special thing, the plus or minus, like in the quadratic formula, in front of the square root. So if you remember in the quadratic formula, negative b plus or minus the square root, you have to put that right there. So now we bring down what we're left with. So the x plus 4 is left on this side because the squared canceled out, and the plus or minus square root 26. I say to myself, can I take the square root of 26? I check it on my calculator. I can't. So all I have to do is get solve for x, the last step. So I just want to get the x by itself. I have to get rid of this plus 4. So I'm going to minus 4. And whatever you do to one side, you have to do to the other. So the 4's cancel each other out. And the x comes down. Equal sign doesn't move. And then I write negative 4 plus or minus the square root of 26. So I have my two different answers, like in the quadratic formula. X equals negative 4 plus square root 26. X equals negative 4 minus square root 26. If they ask you for a decimal number, you just type that in your calculator. Negative 4 plus square root 26. Negative 4 minus square root 26. If they ask you to simplify the radical, you do that exactly like we learned. And that's it. Hey guys, now we're going to do a second example. So in this example, our first step is the same as all these methods, which is get it equal to 0. So right now I have a 14 right here, positive 14. So to cancel that out, I subtract 14. And whatever I do to one side, I do to the other, and make sure to do it to the like term. So you end up with 2x squared plus 12x minus 224 equals 0. And I put that in my calculator by typing negative 210 minus 14. Now, second step, I divide by a. So I wrote the steps here in really short term. So my a is the number in front of the x squared, and in this case, that's 2. So I'm going to divide everything by 2. Whatever you do to one side, do to the other. And you end up with x squared plus 6x minus, I'm going to use my calculator, 112 equals 0. Awesome. So now, next step is move the c over. So to move that, the c is the number with no variable. It's negative 112, so I put positive 112. Do the same to the other side. And you have x squared plus 6x. We leave the space, equals 112, and we leave the space here. Awesome. Okay, so now this is the part that gets a little tricky, but it's not too bad. You just have to think to yourself, what number plus itself gives you 6? Oh, it's 3. 3 plus 3. So really what you're doing is you're just taking that number 6 and dividing it by 2, and that gives you 3. You're taking half of it. And then you just square that number, multiply it times itself. So 3 times 3 gives you 9. So we add 9 here. Whatever you do to one side, do to the other. Next step is we're going to factor. So now we already found our number. We know that it's 3 plus 3 and 3 times 3. So it's x plus 3, and it's positive because the 6 is positive. And we add these together, and 112 plus 9 gives me 121. Okay, so it's the same thing twice, so I can just write it in this short way. X plus 3 squared. Okay, next step, step 5, is square root both sides. And don't forget to put the plus or minus. So when we take the square root, that's going to cancel out the square. And then we do the square root on this side, and we put plus or minus. We bring down what's left, x plus 3, because that's not canceled out, equals plus or minus square root of 121. And now I say to myself, can I take the square root of 121? And I can. The square root of 121 is 11. So x plus 3 equals plus or minus 11. Okay, give myself a little bit more space. And then the last step that we have to do is just solve. Okay, so to do that, I have to get x alone, cancel out that plus 3 by minus 3, and you have x equals negative 3 plus or minus 11. Just like in quadratic formula, we split that into our two problems, negative 3 plus 11, and x equals negative 3 minus 11. And now we just do both of those. So x is equal to positive 8, put it in the calculator, and x is equal to negative 14. And those are your two solutions. That's it. Good job, guys.